Now we have Dušan Zamurović, and he will talk about advanced techniques for data pipeline orchestration. Dušan is an engineering manager and technical lead, team lead at Foursquare. His current focus is motivation teams and building data pipelines, transforming GPS pings into people's movement patterns. He spent part of his career as a data architect, building large-scale data processing platforms, mostly in AWS. So I want to welcome him.
Thank you. Thank you everyone for coming. It's a packed room. I didn't expect this, so maybe there will be some questions at the end of the talk. And as announced, we will talk about maximizing airflow and advanced techniques for the data pipeline orchestration. First, a little bit about myself. I'm currently working as an engineering manager, leading movements team in Foursquare. Previously, I was leading as a technical team lead and engineering manager data platform tools team, in which our main responsibility was maintenance of our orchestration tools. And you will see how many of them we have and how we are using them. And this is where most of the knowledge that you will see in this talk I am taking from. I worked previously as a data engineer and architect. I'm building data platforms since 2016, roughly, and I'm dealing with orchestration problems from even before that. Before we continue, a minor disclaimer that some of the images in this presentation are generated by a tool that is called Foursquare Studio. That's Foursquare's visualization and computational tool for working with the geolocation data. Other images are generated using ChatGPT, obviously. A little bit of Foursquare history, just to set the stage about the tech stack and about all the orchestration tools that we have. Foursquare was founded in 2009. Back then, it was just a mobile application in which you could check in all the venues that you're visiting. You were getting some badges, and if you were most of the times in that particular location, you were like a mayor of that location and something like that. After many years, Foursquare transformed into business to business, and now we are basically building a platform for processing geolocation data, which is movements of people and places and everything that can be built on top of that. In 2019, Foursquare acquired a company called Placed, which was also like a location-driven marketing platform. Then next year, we acquired Factual, another location data company, and then 2021, we acquired Unfolded, which was a company that was built on top of something that was released from Uber as an open source tool. That's the Foursquare Studio. Previously, it was Unfolded Studio. Now it's Foursquare Studio. Now, if we have data analysts and people working in SageMaker, I think when you are visualizing some geolocation data in SageMaker, what you see is actually Studio packed into AWS. Orchestration tools that we have currently in Foursquare are coming from Foursquare, from Placed, and from Factual. In Placed, people in that organization developed their own orchestration tool called Elmer. It's basically a Ruby library, and it uses Jenkins as a running platform and scheduler. Not great. And what this Ruby library does, actually, you supply it with configuration and specification of what you want to be done, and then it transforms that compiles it into really, really big JSON, and that sends it to AWS EMR or other services that can be used for computation. Other tool that we have in Foursquare is Luigi. It's the open source scheduler and orchestration that was developed by Spotify. Python framework for orchestration, basically. I don't want to go into any details. A lot of documentation is available online. And from Factual, we got Airflow. And this is the, again, Python-based tool, workflow management. the main building unit in Airflow is a DAG, Directed Acyclic Graph, which basically describes the hierarchy of the tasks that you want to be performed. Like, what are those tasks? The task can be like copy this file from this place to this place, or it can be send this Spark application to EMR, or whatever basically you come up with. Before we go into the problems that we have in orchestration at Foursquare, I think it's very important to set the tone in terms of what's the scale of what we are dealing with. Now, these are old numbers. I don't want to even look at the new numbers, because last time I checked, there was more than 650 jobs running in Elmer. So basically 600, 700 jobs in Jenkins, which are somehow tangled together or not. About 250 of those are actually EMR Spark pipelines. Some of those pipelines are actually Spark. However, some of those jobs are actually Spark. However, others can be very old ones, which are in Scalding or MapReduce or who knows what. In Airflow, we have, let's say, 500 DAGs. Most of them are complex, not as simple as 3 tasks or something like this. Most of them are very, very complex. In essence, that means that we have roughly, probably more than 5 million tasks running monthly. So we need some kind of big infrastructure to run this. And Luigi, I didn't check. I didn't want to check. Obviously, the ultimate goal is to have one orchestration tool in your organization. And our goal is to have everything in Airflow. When we finally achieve this, which we still are trying to do, we will achieve that goal, which I like to call tech-org integration, because until we have Luigi, since we still have Luigi and Elmer running, I cannot say that we fully integrated those tech stacks from other companies. So we are still in progress with that. And why Airflow? Why have we chosen Airflow? We chosen Airflow because we have most in-house knowledge about Airflow. We know more about Airflow than we know about Luigi or Elmer. Airflow has nice visualization of DAGs, such as this one, but also there are, you can see the graph of which tasks runs first and which branches are there in your DAG, and the order and the hierarchy of the tasks. Nice visualization. It's very important. Airflow is highly customizable, which means you can easily put your logic in, not only in the operators, but in the libraries that you're using. And one of the tasks of the team that I was working before, the data platform tool, was to actually provide other teams with the libraries that they need for their daily job. How we did that? We usually put them in our Airflow deployment. So basically, they say, we need this, we develop a library, we package it with the Airflow, we deploy it, and everybody has it and can use it. It's scalable. We have run our Airflow on top of a Kubernetes cluster. However, now we are changing that a little bit. We are working with Astronomer, and part of our Airflow infrastructure is being hosted and maintained by Astronomer organization. And also, there are many Airflow provider packages, integrations, so basically everything with communicating with AWS, for example, which is the most important for us, you have it as an open source. And then for Data Hub, you have it as an open source. So basically, we are relying on open source packages and standing on the shoulders of the giants, as we say. And now we reach the point of this presentation when I want to talk about the problems and most common issues and pitfalls that I've noticed people make and people face when they are working with Airflow. First one is doing too much at the top of level of the DAG. What does it mean? A DAG is basically a Python script that is being evaluated by Airflow scheduler every minute, every 5 minutes, depending on how you configure that in your Airflow deployment. You specify your tasks and your task hierarchy in the Airflow by using operators. And you say at the end of, usually at the end of the DAG, depending on the complexity, that task 1 runs first, and then after task 1, there should be tasks 2 and 3, and then maybe task 4 or something like this. That's okay. But what you write in the middle between those tasks, between definitions of your operators and between defining what those operators will be doing, if you put that on the top level of the DAG, which means immediately right after you say with the DAG, blah, 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 do this, this, and this, that is being evaluated every time when Airflow parses your Python script, which means if you put there any communication with the database, for example, outside of any operator, or you are invoking any external API, you should do that in operator, not on the top level of the DAG. This means that if you do this on the top level of the DAG, you are actually making Airflow scheduler making those calls every minute or every 5 minutes or whatever your parsing interval is. Now, that may not seem that bad because you say, oh, that's only every 5 minutes. Yes, but then when you have 1,000 of DAGs, as we will have one moment, and when you have all those DAGs running for a long, long time, because some of the DAGs, some of the jobs that we have are running for, you know, well over several hours, then you are facing potential issues because you're putting a lot of pressure on your scheduler, on your Airflow scheduler. As a result of that, your scheduler will slow down and your tasks will not be scheduled in a pace that you want. So some things might get late just because of this silly approach error, let's say. So this is the first one, and this is, I would say, a rookie one. Then, using too many slots. Now we want to define what is a slot in Airflow and what is a pool. A slot we can understand as one logical, let's say, a box where Airflow will put your task that you want to run, right? And a pool is, again, a logical category that defines how many slots you can run at the same time. Obviously, you can have many pools at the same time. But if you, for example, say that default pool has 1,000 slots, and then you are writing your DAGs that they are running multiple tasks at the same time, or you are having tasks that are using more than one slot at the same time, or whatever. Or you have, for example, you have a DAG that is really complex, but it's written that is running many times in parallel. You might get in a situation that you are using many slots at the same time. You might be hitting the limit of that particular pool in which your DAGs are running. That means that Airflow will not go over that limit, and basically your tasks, again, will not be scheduled in time. So what do you do by that? Then you move some of the DAGs into separate pool, set the limit on that pool, and basically logically separate some DAGs from others. Why this exists? This exists because this is the tool that Airflow gives you to save your underlying structure, for example, infrastructure. For example, our Kubernetes cluster that is actually running the Airflow, if we didn't have this, if we would just let Airflow run everything at the same time, then we would face issues with the Kubernetes cluster, and maybe our costs would explode, or who knows what. So basically, this is one also to pay attention to. Then, misuse of sensor scheduling. What is Airflow sensor? Airflow sensor is a specific type of operator which is basically waiting something to become true. I would say the simplest explanation of the sensor is when you are waiting for some resource or let's say file to become available on some location in S3, for example. Then you say, okay, this is S3 file, sensor, or whatever it's called, I don't know by heart. And you say, first time I'm triggering a sensor, and sensor is waiting for this file to show up, and when the file shows up, then the next task in line will take over and will start working. If you know that this file will become available in, I don't know, a couple of seconds after your sensor has been activated, or a couple of minutes, that's not a big deal. However, if, as we do, if you do have a situation that you don't know when that file will become available, maybe in half a day, then it does make difference how you schedule your sensors. So default mode for running a sensor is a poke mode, which means that sensor is checking if the file is over there fairly often. I think the recommended maximum interval is 1 minute. So every minute poking if the file is there. In this case, if you're using sensors in the poke mode, what Airflow is doing, it's actually in Kubernetes cluster, it's creating a worker for this sensor. It's creating a pod that will run that worker, and that pod remains alive until sensor resolves itself. Which means if you are running, I don't know, for 12 hours and you are waiting for some file to become available for 12 hours, because we have that, your pod will be alive for 12 hours. Or, as in our case, your pod will die because Kubernetes cluster will shut it down. Why we are doing this, why we set our Kubernetes clusters as like that, because we don't want our Airflow structure to be running for 12 hours. We want it to be snappy, we want it to be fast. So what do you do in that case? You run your sensors in reschedule mode, which means like check every 10 minutes, for example. But in reschedule mode, that means like create a worker, take the pod from the Kubernetes cluster, check if the file is there. File is not there, shut down, destroy the pod. Come back in 10 minutes again. Create another worker, create another pod, check, file is not there, shut down. Which means that by doing this reschedule, you're taking one slot from Airflow, checking something, it's not there, okay, releasing the resource immediately. Again, doesn't sound like a big deal, but at scale can be a problem. Next one is something I personally call heavy operator or heavy tasks. We had a situation in which a person wrote a script, a Python script that is training an ML model, and wrote it as a Python operator in Airflow, and actually let it run as a part of the DAG. And that training of ML model lasted for, I don't know, 15 hours, or I don't know. It was before we introduced the configuration of shutting down the workers in some time. So, and then we had a problem. We had many alarms coming on call, you know, during the night because some things are happening for too long. You don't want your heavy processing to be done by Airflow in Airflow infrastructure. If you take this approach, making Airflow tasks doing the heavy work and long-lasting work, and then you multiply that bad approach with scale that we have, you could hit all kinds of limits. And essentially, it's always, the result is always the same. It's your tasks will not be scheduled in time and your deliveries will be late. And then you will have phone calls from your clients, which you don't want to. So basically, the cure for this is let Airflow be scheduler, let Airflow be orchestrator. Don't let it work, don't let it do heavy work. Move heavy work elsewhere. So if you are doing some computations or any parsing, like if you have a parsing that you say, yeah, I don't need the EMR for this. Like this is, I don't know, 5 gigabytes of one file. I can parse this in pure Python. I don't even need multi-threading for this. This is going to be done in 2 hours. You can put that in Python operator, that's true. But don't do that. Ship it somewhere to, I don't know, AWS batch or some other computational service and let Airflow just activate that script somewhere in the cloud and you are done with it, right? That would be a proper approach. Now this one is coming from Grafana, and I call this greedy DAG. So the most important line here is the yellow one, the one on the top of the graph. That's free slots in Airflow. So you see the drops. Some DAG or some DAGs in these moments were very, very computationally heavy and using many, many slots. I think these were DAGs that are coming from our data governance teams, and these were probably the DAGs that are removing all the data from S3 that needs to be scrubbed. These are long-running, they are heavy tasks, there are many, many tasks, and as time goes by, Foursquare has more and more data, and these DAGs in particular are becoming bigger and bigger. How people from the data platform governance team solve this, they created their separate pool, and basically, logically, they moved their DAGs out of default pool, and now they have their separate space in which they are operating and not causing any slowdown for other teams. This one, I think this one is my favorite because I was on call that night. And I'm not sure if you guys see, but this is 2 in the morning. And this is 4 in the morning, and this is 6 in the morning, and this is 8 in the morning. I went to bed at 1. And then I was woken up. So this is a graph of a scheduler heartbeat. So we need to have, I'm looking at the lines, but never mind. If the line is up, that's good. If the line is down, that means our scheduler is dead. So what happened here? It turns out that, so Airflow has its own database in which you usually don't touch. You are writing DAGs, you are creating your objects, and when Airflow parses and evaluates those scripts, it creates objects, it creates whatever Airflow needs, and it puts it in the database. So for example, if you really want to see how that database looks like, you will see all of your DAGs, all of your DAG runs, all of your tasks, all of the parameters that you are using for the DAGs, for the tasks, everything is in there. So that database over time becomes really, really big. However, what happened here is database could not respond for some reason. And then, because Airflow has that heartbeat and is checking, basically doing select one from, database doing nothing, it's basically checking if scheduler is up. There is this task in particular is being scheduled every minute, I think, and it's checking if communication with database is possible. In this particular case, it wasn't possible, and scheduler was literally dead. Nothing was being scheduled. How we solved this? We went to the database, we listed all the currently running queries. We found 50-something exactly the same queries, which were terribly big. Like you imagine like a SQL query of, I don't know, 1,000 lines with many, many joins, and I don't know, like 1,000 is maybe too small number, I don't know, like a huge, huge, huge query. 52 of them. 1 running, 51 pending. And all of the other queries also pending, because database was killed by those queries. The resolution, find 51 of those, kill all 51 of those, and hope that the one will finish in time, right? It did the trick. And this is exactly, I would say, the culprit of this situation. I wanted to give you this, this slide to understand why it's really, really important to take care how you design your DAG. Like, I see that developers, when they see that Airflow can, parse everything and like can digest everything, they seem like they start to understand, like, how we say, like, paper can endure everything. Whatever you write on paper, it's okay. They tend to act towards Airflow in the same way. So what is this? This is the representation of one DAG. And you see that these are all on the left. These are all task groups. So these groups are made of many, many tasks in them. I expanded only one. There are many others here which cannot be seen. I expanded only one. So these are new task groups. And then I expanded only one of those. And these are not all of them. And then I expanded, and I could do here like a couple of more columns. So what actually broke Airflow and what actually broke Airflow database is someone tried to open this UI in Airflow UI. And Airflow UI was terribly slow to render this because query was getting data back from server, right? And then, as we do, somebody did refresh. And then nothing happened. And somebody did refresh a couple of more times. And then somebody said, like, hey, database is not working, or Airflow is slow. And then from usually the first response is give it some time, right? And then after a couple of minutes, somebody from some other team was, hey, my DAGs are not getting scheduled. And then I got the pager, and then I got to, deal with this. So yeah, this is one fun one, I would say. One of the reasons why we are actually, this was all when we were hosting our Airflow in our Kubernetes cluster. Then we decided that, okay, we are losing a lot of time from data platform teams for tackling these kind of situations. We are going to pay experts to do that for us. We called Astronomer. Whoever is working with Airflow, when you're Googling something from Airflow, you're probably ending on an Astronomer documentation page. So you probably are aware of them. So they are hosting Airflow for us. First couple of months, I would say, were very, very problematic because they were not expecting the load that we had for Airflow and for their infrastructure. Then we said, okay, this is not working, but we pay you. So what we are going to do, we are going to have this in hybrid mode. We are going to have Airflow in our AWS account with our configuration and our infrastructure. You're just going to maintain this. And then when we would join forces, we finally understood how big infrastructure needs to be. And then Airflow ran smoothly for a couple of months. We said, okay, now we can ship the whole responsibility to you. And now we luckily don't have to face these problems anymore because we pay other people to wake up for this. And at the end, before we go into, let's say, discussion or Q&A, my personal impression of Airflow is that it's very, very extensible. It's very, very easily customizable by design, which is very good, which is awesome, right? But it's extensible and customizable to the level of very easy misuse. As I said, this example of a person running ML training in Airflow infrastructure is terribly wrong. And this is like, what prevents you of doing that? You write your Python script, you import it into Airflow as a library or however you make it available, and you say, hey, my Python operator, run this. And that's it. Nothing prevents you from doing this. But doesn't make it right. Being easy doesn't make it right. you need to understand actually how the tools that you are using, how they are working internally in order to use them properly and in order to have, good night's sleep. So, as I said, some operators can be used for implementing this long computations. And in particular, for me, the biggest takeaway with working with Airflow was always think about what scheduler is doing. Because tasks and sensors and operators, they are like, they show up and they go. They are not big of a deal. You can like sacrifice them. You need them to show up and be killed. However, scheduler is part of the infrastructure that needs to remain stable all the time. And your goal as a, Airflow developer, let's say, engineer who is using Airflow, your goal is to have the least footprint of scheduler's workload as possible. That's my, takeaway from all these examples that I gave you. That's the same takeaway from all of them. And this is it. We hit the 30-minute mark. So if you have any questions.
So there are already 2 questions.
Oh. Okay.
How do you manage state or data between tasks?
Between tasks, okay. So state, we don't manage. So our DAGs are not sharing the state, but you are transferring the state using parameters. So using XCOM, basically, you are transferring the output of one task into another one, or putting something in Airflow context and then getting it from there. Other way of doing this is using external resources. So, for example, in cases when we have long-lasting operations, we don't do even that. We tend to write out everything that needs to be written out somewhere in several locations if need be, and then the next task will access those locations if needed.
Okay, thank you. We have another 2 more questions new. Sadly, I think that will be it from questions, because after that, you can get some drinks and croissants. But can Airflow be integrated with Kafka? If yes, how difficult it is?
Yes, it can, and I don't know, because I didn't work there. Yeah.
That's it? Okay.
Yeah, okay.
You mentioned some platform where you run Airflow jobs. What is the platform and why did you choose it?
Come again?
You mentioned some platform where you run Airflow jobs. So
okay,
what is the platform and why did you choose it?
I'm not sure if I understand this, but if we like, what's the platform that we are talking about here? Okay, let me try guess, right? So most of our jobs are EMR jobs. So basically we are submitting Spark applications to EMR and running them over there. If that's the platform, that's the AWS EMR, Databricks. So we are triggering notebooks and jobs on Databricks. We are, for sure, some teams are using Kubernetes operators in which they are using their custom images, custom Docker images to run some scripts on their kind of specifically created workers and pods to run those scripts. We are running, we are trying to move all of our EMR work from EMR on EC2 to EMR serverless. So we are using EMR serverless. That's it. I don't know if that answers this question.
Oh, I hope it does.
Okay.
If there are any other questions, sadly there is not enough time, but you can ask him on a break or something. So I want to thank him for an amazing presentation.